Hello, my name is Alex Lamb, and I would like to talk to you today about something called group selection. A little while ago, I got sucked into a debate on Facebook. You know how it goes. Oddly, this one wasn't about politics. It was about a book I read that I quite liked. It was called The Social Conquest of Earth by Edward O. Wilson. And what this book about was essentially what makes people nice. There aren't that many species in the world that really sort of cooperate and look after each other. Sure, human beings are capable of producing the odd horrific world war, but we also do things like build cities. Anybody who sort of goes and takes a look at a troop full of monkeys will tell you that they're surprisingly brutal to each other. Or you can just go down to your local duck pond and chuck some bread into the pond and basically look at the ducks sort of beating each other in the face trying to get at it. Pretty much the only species in the world that are better than we are cooperating seem to be ants and bees. So what gives? How come that's true? So there are various different competing visions of this, but essentially Wilson, who wrote the book, and his collaborators, they've got a model. Other people say that model is impossible, and on the back of that, there's been an enormous science fight between different warring groups of evolutionary biologists. So I decided to test their idea. So there are basically two competing visions, if you like, in evolutionary biology. One is that niceness, cooperation, whatever, comes through inheritance. What's called kin selection. Essentially, parents are nice to their kids. Kids that are nice back to their parents, and so on and so forth. Essentially, niceness comes out of people looking after people they're related to. And the other vision is, if you like, that niceness, cooperation comes out of coexistence, when entities are forced to live together in groups. So you might characterize these two visions as we look after our own versus we're all in this together. And from this, though, you might think that the subject of cooperation would encourage people to be nice to each other, but in science there's been this enormous debate. One side is people like Richard Dawkins, who's saying, those guys don't understand genes. And on the other side, you've got Edward Wilson, people like that, and they're like, those guys don't understand math. And everyone else is, what? Nobody else really knows what's going on. But we can find out. That's what's interesting about this particular question. And we can find out by building simulations. And here's the funny, dirty secret in the world about science questions of this sort. Anybody who can cut 2 pages of code can find out for themselves. And so that's what I decided to do. I decided to visit the matrix. So what did I do? I built a simulation in which there's 2 kinds of agent, and they are, broadly speaking, what you might think of as a cooperator. And that's the sort of, like a little sort of software person. They do nice things for others in the hope of reciprocation, but they don't necessarily get things back. They're like, here, have a gift. And then hope that something nice is going to happen afterwards. And then you've got defectors, and defectors are the sort of, they're like equivalent little robot agent people. And what they do is they accept nice things. They say, oh, gee, thanks, a gift. And they never reciprocate, they just keep it. We all know those kinds of people. But anyway, we put the agents together and we make them live in tribes, little kind of digital pockets where they can live. And then what we do is we make a lot of tribes. So the simulation's got a whole bunch of tribes that are happening in parallel. And then every day in our simulation, tribe members meet and interact with each other. And tribes that basically give a lot and don't get anything back, they can run out of health and die. But agents who do succeed, they reproduce if they're healthy enough, and if they do reproduce, they can give rise to basically copies themselves. But of course, there's a chance every time they reproduce that they might produce a mutant, somebody who is a little bit different from themselves. Anyway, every year in the simulation, our tribes sort of bounce together and they exchange a few members. Also, tribes that have a lot of kids, they can split and become 2 tribes. And tribes are competing with each other. So some tribes may just die out. If they're doing a terrible job, they can get involved in a war or a bad winter or something, and the whole tribe dies out at once. So what happens? You build a simulation like this, it doesn't take that much code. Does the fact that tribes live or die together affect what kinds of agents are likely to thrive? If group selection is right, then we'd expect cooperators to win out, even when the people living in those tribes might be unrelated to each other. If group selection is wrong, we'd expect the reverse. We'd expect basically the whole thing to just die out. So we can find out. We can go to the Matrix. We can have Matrix time and find out what happens. So tune in to the next exciting video in this series to discover what happens when we run the simulation. But also, I'm a science fiction novelist. I write books as well as simulations, and you can find me in these things. Tune in next time, folks, for fun, happy adventure science times.